All right. Could part 2 possibly be more fun than part 1? No, we had too much fun. I'm sure it's equally as fun, I'm sure. All right. So anyway, what did we do? We kind of introed percents. We looked at these two different ideas: percent proportion, percent equation. We kind of looked over a little visual of what this is all about. We did some practice. We did finding the part, just finding the part, okay, or finding a percent of a number. Now we're jumping down to finding the whole. All right, just a little reminder. Here's my proportion. Here's my equation, and we can do it either way. In this case, we are looking for the whole. We're looking for what it started with, so that when we took the percent and we got that little answer, we're looking for what we start with. So let's read this one. Paul made 40% of his foul shots in the basketball game. If he made 6 foul shots, how many shots did he take? How is this different than the one we did before? It seems similar. I mean, it's a different person, Paul. But what's different here? Well, okay. This number here, is that referring to all his shots? No, it's just the ones he made. So that's some of his shots. That's a part of his shots, right? So if we set up this proportion, we can't put 6 on the bottom like we used our numbers before. We have to think through. We have to read carefully, and we say, wait, 6 is the part. 6 goes up top. See? The part goes on the top, right? And what are we looking for? It says, how many shots did he take? That's how many shots he took altogether. So we don't know that. All right, we do know that 6 is 40% of that number that we don't know. All right, so then we cross multiply, we divide, and we get 15 shots. Woohoo, 15 shots. So practice that, multiply and divide, and see if you can get that. Now, remember, just copying, that's not going to really help you out. You have to really think about the answers, think about the process, think about why we chose to do what we did. All right, now we got percent times whole equals part. We're going to try it with the percent equation. Now this will take some practice, but some of you will get really good at this method. It's percent times the whole. The whole we do not know. We do know that what we get when we take the percent of the whole, we know that it's going to come out to 6. Now you have to realize multiplication and division are kind of like inverse operations. So if you can't do the multiplication because we have an x there, then we have to find that, to find out what you would multiply by we're going to divide. Do the inverse operation. Okay? So we're going to get x equals, and then if you do 6 divided by 0.40, you get 15, and that's 15 shots. All right? Same. All right, let's go to the next one. Zoom. All right, 20 is 35% of what number? 20 is 35% of what number? So in this case, 20 is the piece. 20 is 35%. So you see the 35. We're going to put that on top. All right. And then we say, well, 25 is 35. So, 20 is 35. So that goes up top. And then what follows that special word of? There's that special word. Special word of? Of what number? It's saying we don't know the whole in this case. So that goes on the bottom. All right, now we're going to multiply those ones that are next to each other, or diagonal from each other, and divide by that guy. And we get, and that comes to a kind of strange number. I'm going to use a special symbol here. Quiz you on it when I get back. That little squiggly equal sign means approximately. Approximately, not quite exactly equal to, but close, very close. Yeah, we're going to round. So when I divide that, it comes to 57.1428571, which I'm just going to round it to the nearest tenth. It's kind of random that I'm just rounding, but I made a mistake when I made this problem. It shouldn't have come to a weird answer, but we're going to just go with it. So 57.1. All right, so 20 out of 57.1 is the same as 35 over 100. Okay, so let's go. Let's keep it moving. Let's go. If we have the percent 0.35 times the whole, which we don't know, and we get 20, we're going to then divide this by 0.35, and x equals, we know 57.1. Oops, it's not exactly 57.1, so we put that approximately symbol. Hopefully this one I didn't mess up. Let's read it. 60% of what number? So let's go with the proportion. 60%, right, of what number is 24? Excuse me. Oh, we see that of word, and right after that we see the word what number. So that means it's our variable. It's our unknown. It's the thing we don't know. And then is 24. So 60% is 24. Okay, 24 is 60% of what number? We could restate it like that, but a lot of times the word that is either before or after the word is going to be our part. All right, so that's a different setup. See these two? They're different. In this case, it said 20 is 35% of the part was at the beginning. Here, the part is at the end. But this kind of phrase here is the same. See, 35% of what number? The percent and the whole are usually like next to each other with the word of right in there. You see? So 60% of what number? 35% of what number? All right, so those are usually linked like that. Anyway, let's go back to the problem. There we go. We got to multiply that, divide by that. And shoo, it comes to a nicer number this time. That comes to 40. All right. Good. All right, so 40. So I meant to do this earlier, but we're going to say 24. Wait, I'm just going to restate that sentence, but this sentence here, but I'm going to put in the number. We got 60% of 40 is 24. Makes sense because 24 is like a little bit more than half of 40, and 60 is a little bit more than half of 100. So that makes a lot of sense to me. All right, now we got to do percent times the whole equals the part. Percent is 0.60 times we don't know the whole equals the part. Equals is a lot of times the word is. So it says is 24, so it kind of helps you know that the 24 is going to be after the equal sign. Anyway, it's multiplication, but we don't know that multiplication part, so we reverse it, or we kind of do a fact family of 24 divided by 0.60, and we know from our previous problem that comes to 40. All right, so here we have our answer. This confirms that answer. And we're on to our last part of this problem. Oh, good. This was a lot shorter than our last lesson. Okay, Jay just scored 85% on the test. She got 17 problems correct. How many total problems were on the test? Well, let's see here. How many total problems? Look, it's asking that. So that means we don't know that. Well, that sounds like the whole to me. Right? Is this the whole? 17 problems correct? No. She got an 85% on the test, so she had to have gotten some wrong. So 17 can't be the total test, right? So we're going to put 100 here. She got an 85. And those 17 problems represent the 85%, right? And we don't know the whole that would go next to 100%, all right? So 17 out of what would be the same as 85 out of 100? Well, let's go. And then we're going to divide by that. Yay, another neat, beautiful whole number. X comes to 20. What does that mean? 20 problems on the test. That makes sense. 20 problems on the test, so 5 points for each one if it's out of 100%. So, yeah. 3 times 15. 3 wrong, 5 each. That's 15. 100 minus 15 is 85. Sorry if that was quick maths there, but Just flexing my brain muscles. Anyway, next problem. So we're thinking, okay, that percent times the whole. We don't know how many problems there were, but we know the result of that multiplication would be 17. So to reverse that, we have to divide by 0.85, and we get 20. All right. There we have it, our next part of our notes. Good luck. Hope you followed, and hope you're getting a better understanding of how we work with percents. Okay, sayonara.